Welcome students. This video is continuation of the earlier video, that is graphs and their properties, transformation of graphs, its applications. In the earlier videos we have done transformation up to 4. Now next, graphical transformation 5. Fx is replaced by minus fx. Fx is replaced by minus fx. So for example, number 1, y equals to e to the power x, transform to y equals to minus e to the power x. So look, y equals to e to the power x. So it is done many times. This is y equals to e to the power x. Now to draw f of minus x, f of minus fx, that is minus e to the power x. Look, this is e to the power x. You have to take mirror image of the graph about x-axis. About x-axis. So look, this is 0, 1. So mirror image. This is y equals to minus e to the power x. So what is the rule? Draw y equals to fx, that is e to the power x. Take the image of fx about x-axis. This is x-axis. About x-axis. Very simple. Next, one more application. Number 2, y equals to log x base e. B, y equals to log x with negative sign. So fx minus fx. So first we have to draw graph of log x. Graph of log x. So log x at x equals to 1, value is 0. So 1. So x equals to minus infinity. So log, this is asymptotic behavior. Then this side. This is y equals to log x base. Now y equals to minus log x. So look, mirror image of this about x-axis. So this is like that. Mirror image of this about x-axis. So this is y equals to log x with negative sign. So how to draw fx to minus fx? Next, transformation 6. fx is replaced by minus of minus fx. So first write application y equals to e to the power x. This is a. Y equals to minus e to the power minus x. So y equals to e to the power x. So look, so this is 0, 1. This is e to the power x. Then y equals to e to the power minus x. E to the power minus x. E to the power minus x. So this one mirror image about y axis. So mirror image about y axis. So this part. So this is mirror image. And mirror image of this about y axis. For this part. So this is y equals to e to the power minus x. Now look, we know e to the power minus x. So by the earlier knowledge, we can find minus e to the power minus x. That is mirror image of this graph with respect to x-axis. So look, figure will be like that. So this is y equals to minus e to the power minus x. So what is the rule? To draw. So write first draw fx to f of minus x. That is mirror image of fx about y-axis. So fx to f of minus x. Next, draw minus f of minus x. That is mirror image of f of minus x with respect to x-axis. So fx to minus fx. Next, so these are most important for solving problem using graph. So number 7. fx2 f of mod x, fx2 f of mod x. So take an example, y equals to log x. Number b, y equals to log of mod x. First we take an example. Next, look, we are repeatedly drawing graph of same part, log x, e to the power x, and so on. So log x equals to 1. This one is y equals to log x. Y equals to log x. So what is the rule? Take mirror image of the graph about y-axis, and neglect the part for x less than 0. So there is no part for x less than 0. So you have to take mirror image of this part about y-axis. This is 1, 0. So this one is 1, 0. So figure will be like that. And this is increasing nature. This type. Mirror image of this. So what is the rule? The rule is, number 1, draw y equals to fx. Number 2, to draw f of mod x, we take mirror image of y equals to fx about y-axis for the portion of x greater than 0. So look, this is y equals to x. So all for greater than 0. So this is y-axis. Take mirror image of this one. So this is y equals to log of mod x. Y equals to log of mod x. Next, second application. Y equals to e to the power x. 2 y equals to e to the power mod x. Y equals to e to the power mod x. So e to the power x. So 0, 1. This one is 0, 1. Hello, how many times you have drawn it? Many times. Look, this is y equals to e to the power x. Now, this part is greater than 0. So take image of this part about y-axis. Image of this part about y-axis. So image of this part about y-axis. So this part is cancel out this part. So image of this about y-axis. So this one is e to the power mod of x. This graph is e to the power mod of x. So draw y equals to fx, delete negative x part, take image of positive x part about y-axis. Then, how interesting, you look. Y equals to sin x. Y equals to sin of mod x. So look, this one, this is 0, pi, 2 pi. 0, pi, 2 pi. So maximum value is 1 and minimum value is minus 1. Then this is minus pi, minus 2 pi. So minus 2 pi. So sin pi by 2 minus 1. So this is sin x. Y equals to sin x. Y equals to sin x. Now look, what is y equals to mod sin x? What is y equals to mod sin x? So this part is for x less than 0. So omit this part. Next, image of this part by y-axis. So figure will be like that. This one, and image of this part by y-axis. So what you are getting, this type of curve. So this is y equals to sin mod x. Look, image of this part is this one, and image of this part is this one. So y equals to sin mod x. You know y equals to sin x, this is very simple. Now y equals to mod x is obtained by this rule. Next, transformation number 8. Y equals to fx to mod y equals to fx. Mod y equals to fx. So take an example first. One A, y equals to sin x. B, mod y equals to sin x. Mod y equals to sin x. So we first draw it. Then we write the rule. So this is pi, this is 2 pi. This is minus pi, this is minus 2 pi. Maximum value 1, minimum value minus 1, this is 0. So look, this is the range. So So 0 to pi, figure will be like that, pi to 2 pi, minus pi, and this is 2 pi. So this is y equals to sin x. Now what is the rule for mod y equals to fx? So rule, neglect portion of graph y equals to fx below x-axis, below x-axis. Number 2, take mirror image of the remaining portion with respect to x-axis, with respect to x-axis. So look, neglect the portion of the graph y equals to fx below x-axis. So this portion is neglected. This portion is neglected. Then, so this is the remaining portion. Take the image of this part by x-axis. Take the image of this part by x-axis. This is minus pi, this is minus 2 pi. So this is graph of y mod y equals to sin x. Mod y equals to sin x. Next, one more applications of it. So look, y equals to x minus 1 into x minus 2. And what is b? Mod y equals to x minus 1, x minus 2. Look, it is very easy to draw graph of parabola. So draw graph of parabola. So x-axis, and this is x-axis. This is y-axis, x dash, y dash. So there are two methods, you know. Look, it cuts x-axis at 1 and 2. So this is 1, this 2. 1 and 2. So this is 1, this is 2. So their midpoint will be the vertex. So now here coefficient of x square is positive. So it is upward. Open above x-axis. So figure will be like that. This one approximately. So x minus 1, x minus 2. Look, now you can draw graph of mod y equals to this. So what is our rule? Delete below x-axis. So this is 1, 0 and this is 2. This is deleted. Take image of this part with respect to x-axis. So you are getting figure like that. and here you are getting like that. So this one. So this figure is mode of this one. This mode of this. There are so many transformation, third bracket x also. So these are sufficient. These are regarding transformation of graphs. First, graph of function y equals to mod x log x e to the power x. Then greatest integer, then transformation. Now main part, that is application of graph. In Transcedental equation, how to solve? So write solution of equation. Solution of equation using graph. Using graph. Solution of equation using graph. So write solve cos x equals to x. Number 1. Solve cos x equals to x. So look, by our ordinary method, we cannot find x. Solve means not solve, sorry, find number of solutions. Find number of solutions. We are not interested about the value of x. How many solutions? How many solutions we are getting? So, to see this, you have to draw graph of cos x and graph of y equals to x. So look, y equals to cos x. So 0, this is 1. 0, this is pi by 2, this one is minus pi by 2. Then again, pi, 3 pi by 2, minus 1. So this is figure of y equals to cos x. Now y equals to x. Now look, pi, then minus pi, minus 3 pi by 2. So you get figure like that. So y equals to x is a line passing through origin and bisecting it. How many solutions we are getting? Look, only one solution. So number of solutions equals to 1. So this one. Next. Now we are getting how many solutions? Number of solutions 1. Now look. So look, why this y equals to x? It is obvious that y equals to x does not cut this curve for x greater than 0. But you may think this line may cut this part. But look, this is not possible because at x equals to, suppose this is 3 pi by 2, this is 3 pi by 2. What is value? Value is minus 1. This value is minus 1. But for y equals to x, so at x equals to 3 pi by 2, y equals to 3 pi by 2. Y equals to 3 pi by 2. So look, y equals to x, and x equals to minus 3 pi by 2, y equals to minus 3 pi by 2. Minus 3 pi by 2, this is greater than. So look, this one is minus 1. So this one, if you calculate it, minus 3, that is minus 1.5 into pi. Pi means 3.14. So this one is minus and this is greater than this. So it does not cut. This curve does not cut y equals to x. So we are getting only one solutions. Look, for here it is shown, this is pi by 2, this is pi, this is pi. Actually, sorry, this one is pi, this one is pi. So y equals to not 3 pi, this is pi. So x equals to minus pi, y equals to minus pi. So minus 3.14. So this one up to this one is minus 3.14. So it does not cut it. So we are getting only one solutions. Next, look, y equals sin x equals to x. Sin x equals to x. Find number of solutions. So look, this is y equals to x. Bisect it. Y equals to x. So if we draw y equals to sin x, 0 to pi, figure will be like that. Now, you may think, how many solutions? 0 and this one, 2 solutions. 0 and this, 2 solutions. But this is not the case. This figure is wrong. Suppose for pi by 2, if we take this as pi by 2, if this as pi by 2, so what is y equals to pi by 2? So 3.14 by 2. So 1.57. 1.57. Actually, this is pi by 2 and 1.57 is greater than it. So actual figure will be like that. Actual figure will be like that. Look, 0 to pi, 0, and suppose 0, this is pi, and figure will be like that. This one figure will be like that. This is y equals to x, and this is y equals to sin x. So how many solutions? Here, for you write x greater than 0. So how many solutions? Only one solutions. For x greater than 0, so how many solutions? Only one solutions. But if you draw a graph like this, you may think that there are 2 solutions. But this is not the case. If you draw the graph, you look for pi by 2, for pi by 2. So what is the value? For pi by 2, this is 1.57. But this one, 1.57, this one is 1.57, and this one is 1. So it does not cut, it only touches at x equals to 0, tangentially. So number of solutions equals to, what is number of solutions? Number of solutions equals to 1. Next, e to the power x equals to x to the power 4. Find number of solutions. Look, we are not interested about the solutions, number of solutions. So look, this is x to the power 4, 0, 0, at x equals to 1, this is 1, at x equals to minus 1, this is 1. So this is like parabola, and what is e to the power x? E to the power x, 0, value is 1, so figure will be like that, this is y equals to e to the power x, this is y equals to x square. So how many solutions? Look, 1 and 2. Number of solutions equals to 2. Number of solutions equals to 2. Next, find number of solutions of log x equals to minus x. Log x equals to minus x. So draw the graph. Log x, we know 1 it is 0, so figure will be like that. Look, easily you can find number of solutions. So what is y equals to minus x? Passing through origin, making an angle minus 135 degree. So number of solutions 1. Number of solutions equals to 0. 1. Number of solutions is 1. So look, draw the graph of log x, draw the graph of minus x, solve, and you find number of solutions. Next, number 5. So root over 1 plus cos 2x equals to root 2 sin inverse sin x. Sin inverse sin x. So what is the restriction here? Restriction minus pi less than x less than pi. One restriction is given. Look, this is root 2 into cos square x, that is mod cos x, equals to root 2 sin inverse sin x. So root 2 is cancelled. Now you draw graph of mod cos x and sin inverse sin x. So look, up to pi, this is pi by 2, this is pi, this is pi by pi, and this is pi by 2, minus pi by 2, this is minus pi. So what is range of sin inverse sin x? So look, you know minus pi by 2 to plus pi by 2. This is, we have already drawn in previous class. This is y equals to x. Y equals to x. So this is 0. This is x-axis. This is x-axis. So y equals to x. this is minus pi by 2, sorry, plus pi by 2, and this one is minus pi by 2. Then you know graph is like that, this one, and for this, look, minus pi to 3 pi. So this is the figure of y equals to sin x. So this is y equals to x. This is y equals to x. Figure of sin inverse sin x. You know minus pi by 2 to plus pi by 2. This is y equals to x. Now mod cos x. At x equals to 0, it is 1. 1 means this is pi by 2 greater than 1. This one. At x equals to pi by 2, it is 0. It is 0. So you get this one. This one. Then this is pi. So what is pi? Cos pi. Cos pi is minus 1. Cos pi is, so pi by 2 pi. Cos pi is minus 1. But mod of cos pi, this is plus 1. This is plus 1. So you get figure like that. This one. And for this, you are getting figure like that. This. They are of same line. This. We are drawing graph of mod x. This is graph of y equals to mod cos x between minus pi to pi, and this one is, look, this is one point of intersection. This one is a mod cos x and y equals to x, and this one, this is number 2. This is one solution. This is one solution P. This is one solution Q. Now look, this one and this one, no intersection. So how many solutions? Number of solutions 2. So number of solutions equals to, listen again, cos x, mod cos x up to pi. So it is always above x-axis, mod. So figure is like that. And sin inverse sin x, this is y equals to x for minus pi by 2 plus pi by 2. Then like that. Then it is also, so what you are getting? 2 points of intersection. Next, so sin inverse sin x equals to 1 minus x square. 1 minus x square. Now look, this is a parabola. Y equals to 1 minus x square. So x square equals to y minus 1. So vertex is 0, 1. Vertex is 0, 1. It cuts x-axis. Y equals vertex 0, 1. 0, 1. Vertex is 0, 1. X 0, y 1. It cuts x-axis when y equals to 0. That is x equals to plus minus 1. So this is vertex. So look, coefficient of x square is negative. So figure will be like that. Downwards, it is open, downwards. So this one. Vertex, again look, y equals to 1 minus x square. So x square equals to 1 minus 1. So vertex is 0, 1. So look, 0, 1. So x 0, y1. So this is vertex. And look, this is minus, so this is this type of figure. This is 1 0. This one is minus 1 0. Now you have to draw y equals to sine inverse sine x. So this is 0. Then pi by 2. This is pi by 2. This is minus pi by 2. So this is pi by 2. This is minus pi by 2. So this is pi by 2. So this again is pi by 2. This is minus pi by 2. Minus pi by 2. It is this restriction. So y equals to x between minus pi by 2 to plus pi by 2. So you are getting figure like that. You are getting figure like that. Then look, this is pi by 2, this is 0, this is minus pi by 2. Then pi, 3 pi by 2. So again you are getting figure like that. If it is pi by 2, suppose this is pi by 2 and this is minus pi by 2. So you are getting figure like that. This is y equals to x. Then you get this curve, this, again this. Now look, it cuts the curve here and here. 2. So how many solutions? So number of solutions equals to 2. So look again. Look, this one, y equals to x, and it starts here. And there is also again this part. So number of solutions, this one P, this one Q. How many solutions? 2 solutions. So in this way you can solve. You can find number of solutions of equations. This mixed type of equation, polynomial equation, logarithmic, they are called transcendental equations. So this is the application of graph. Thank you.